Okay, you should have torn out Think Up page 30. We're going to talk about that constant rate of change. So now it says a constant rate of change can be represented in a variety of formats. So there are different ways of doing it. Here we have a picture where it says determine the relationship between the position of the figure and the number of tiles used to create the figure. So if you notice, every time they're just multiplying it by 2. That's 1 times 2, 2 times 2, 3 times 2. So the constant rate of change there is 2. Here in a table, it says determine the ratio of the differences in the values, the y values, and the differences in the x values. So you're finding that change in y, and let me just write that because that's what you should be writing on your paper, that change in y over that change in x. That is that constant rate of change. So if you notice, every time y increases by 10, our x is increasing by 2. So if I put that 10 over that 2, I know that it gives me a constant rate of change of 5. So every time it is increasing, it is a constant rate of change of 5. Here we have a graph where it says that we normally go up our y, because this is our y-axis here, and this is our x-axis. So we go up first, it went up to 3. Then to that next point, it goes over 2. So that means that it is 3, that change in y, 3, over that change in x, 2. And it keeps doing that. Up 3, over 2, up 3, over 2. Then in the equation, it will always be the value that is being multiplied by the x, or that is changing x. That is that constant rate of change. So here in this proportional relationship, being multiplied by that x, that is our constant rate of change. And even if you had an equation that looks like this non-proportional, let's say it's y is equal to 5x plus 10. This 5 would also be our constant rate of change because it's being multiplied by that x. Verbal, when you're listening to the verbal, I don't know why I got so loud, it says that you're identifying the value or the values in a verbal representation that indicate the change occurring in the situation. So here the number of tiles used to create the pattern is 2 times the position in the figure. So the constant rate of change is that 2 in that verbal. Going to our numeric, I don't know when we would really have it like this. Maybe we could. It says similar to a table. You have to figure out which ones are your x, and we know x is always first, and then y is that second number. So every time it's increasing by 1 in our x, it's increasing by 6. So that change in y over that change in x is going to be 6 over 1, which is just 6. So now that's all the different scenarios. So if you need to keep going back to look at that, please do so that you can make sure you're understanding what we are talking about here. So now, as usual, let's go to the try it. So it says, use this information to answer questions 1, 2, and 3. So Zach tracks his community service hours for Boy Scouts. Last month, he provided 4 5/10 hours, or 4.5 hours of service per week. Complete the table to represent the constant rate of Zach's service hours. So he did 4.5 hours of service per week. So that just means that every week he was doing 4.5. So if he didn't have any weeks, we already know that would be 0. If he did 1 week, if we multiply that by that 4.5, it's going to give us 4.5 hours. If we multiply that 2 by that constant rate of change, it's going to give us 9 hours. If we multiply that 3 by that constant rate of change, and let me just do it. So 4.5 times 3, 15, 13.5, 13.5. I multiply that 4 by that constant rate of change again, but I could also do something else. I can add 4.5 to 13.5 because that constant rate of change every time here is increasing by 4.5. And I'll show that in just a minute. So if I do 13.5 plus the 4.5, that gives me 10, 8, and 1. So that means that is 18. But just to show you, every time, if you notice, this is increasing by 4.5. This is increasing by 4.5. Same for that. Same for that. So every time our change in y increases by 4.5, our change in x is always increasing by, you got it, 1. So our change in x is increasing by 1. So that's how we'll get that 4.5 per week. Let's look at number 2, still using the same information. So, sorry for the noise. So we're now taking the x and the y from here to put it here. So we know that our first one is 0 and 0. Our next point is 1. So we go over 1 from our origin to 4.5. That's 5. 4.5 is about right there. We have 2 and 9, so we'll go all the way up to 9. And we have 3 and 13.5, which is about right. If that's 13, it's about right here. And then we have 4 and 18, which is right here. That is our relationship, which is also proportional because it's going through the origin. Now it says write an algebraic equation to represent the constant rate of change as shown in the table and the graph. Well, we already know it's going to be a proportional relationship, so we know that it's going to be in the form of y is equal to our constant rate of change, which is 4 and 5/10 times x. This situation, they have w for the weeks, which is our x value. So if we just write it using those letters, let me erase that. That's why we always write in pencil, which means that our y is h, which is equal to 4 and 5/10 times the amount of weeks. So if we multiply 4.5 by the number of weeks, it's going to give us our number of hours. So I hope that has helped you. Make sure you watch this as much as you need to. Place it also in your ISN on your next available page. And have a marvelous day. Thank you.